A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
You know, Herman, I was looking at some telemetry data from earlier this month, and there is a statistic that absolutely stopped me in my tracks. As of March 23rd, 2026, 4% of all public GitHub commits are now authored by an artificial intelligence agent, not just suggested by one, or partially written, or used as a glorified autocomplete, but fully authored, tested, and committed by an agentic system.
It is a staggering number when you consider where we were just 18 months ago. I am Herman Poppleberry, and that 4% represents a 40,000-fold increase since the early research previews we saw back in 2025. We are not just talking about snippets anymore, we are talking about entire features and complex bug fixes. Today's prompt from Daniel is about Claude Code specifically, and he wants us to dig into why people are calling it an agentic harness.
It is a great phrase, agentic harness. It implies that the model itself, the raw intelligence of something like Claude Opus 4.6, is this powerful, wild force that needs to be strapped into a specific piece of machinery before it can actually do productive work in a production environment. Daniel wants to know what those moving parts are that make a command line interface feel less like a chat window and more like a senior developer who just happens to be a supercomputer.
The distinction is vital for anyone working in software today. Most people are used to a passive chatbot experience where you type a prompt and get a block of text back. You then have to copy that text, paste it into your IDE, run the compiler, and hope for the best. But a harness transforms that large language model from a passive observer into an active participant in the software development lifecycle. It is the difference between asking someone how to fix a leaky pipe over the phone and handing a master plumber a wrench and letting them into the basement.
So let us start with the harness itself. Why that word? Why not just call it an agent? Is it just marketing speak from Anthropic, or is there a structural reason for the terminology?
There is a deep technical reason. Because the model, even something as flagship as Claude Opus 4.6, which launched back on February 5th, is still fundamentally a stateless prediction engine. It does not have a hard drive. It does not have a terminal. It does not have eyes to see your file structure or a way to feel the heat of a failing test. The harness is the specialized wrapper that provides those biological equivalents. It manages the state, it handles the recursive reasoning loops, and it provides the execution environment. Without the harness, the model is just a very smart brain in a jar. With the harness, it is an entity that can run a bash command, read the error output, and then decide to try a different approach without you ever saying a word.
That brings us to what you call the agentic loop. I think this is where the magic happens for most developers who are trying Claude Code for the first time. It is that three-phase cycle of context gathering, action execution, and result verification. Can you walk us through how that actually functions under the hood?
That is the heartbeat of the system. In the context gathering phase, the harness is not just looking at the file you have open, it is traversing the entire directory. It is looking for a file called claude.md, which acts as the project-specific rulebook. It is reading memory.md to see what it learned during the last session. It is building a mental map of the codebase before it even suggests a change. It is essentially doing the onboarding process that a human developer does, but it does it in milliseconds.
And then it moves to execution. But it is not just writing code to a window for me to copy and paste. It is actually hitting the file system, right?
It is using the tool use capabilities of the model to trigger specific bash commands. If it needs to refactor a function, it does not just write the function. It uses a tool to find the line numbers, another tool to replace the text, and this is the crucial part of the loop, it moves to verification, it runs your test suite, it checks the linter. If the tests fail, the harness sees that failure is a new input. It does not stop and ask you what to do. It looks at the test failure, reasons about why it happened, and starts the loop over again. It might go through 5 or 6 of these loops before it ever presents a solution to you.
I find the visibility of that reasoning process to be one of the most interesting technical shifts recently. With the release of Opus 4.6, we saw this move toward a hybrid reasoning architecture. They gave us this thing called a thinking budget. I have seen people setting these budgets to massive levels.
The thinking budget is a game changer for developer trust. You can allocate up to 128,000 tokens for what is called extended thinking mode. When the harness is working on a complex problem, it actually shows you that internal chain of thought. You can see the agent planning its route, weighing the pros and cons of different architectural patterns, and essentially talking to itself before it touches your code. It is using those tokens to simulate the outcome of its actions before it commits them to disk.
It feels like watching someone think in real time, and because that thinking is happening in a high-density token space, it can handle much more complex logic than the old-school prompting methods we were using in 2024. But what happens when that logic needs to go outside the codebase? Daniel's prompt mentions the Model Context Protocol 2.0, or MCP. How does that fit into the harness?
Think of MCP as the universal adapter. It is standardized on JSON-RP C2.0. Before MCP, if you wanted an AI to talk to Jira or Slack or a PostgreSQL database, you had to write custom API integrations for every single tool. Now, the harness just connects to an MCP server. There are over 2,000 open source MCP servers available on NPM right now. This allows Claude Code to pull in context from your bug tracker, look up a schema in your database, and then check a Slack thread to see what the product manager actually wanted, all within that same agentic loop. It is bridging the gap between the code and the business logic.
It is basically giving the agent a set of hands that can reach into any part of the enterprise stack. But there is a massive security implication there that I think we need to touch on. There was a report from SC Media just a few weeks ago, right around mid-March, that found nearly 7,000 internet-exposed MCP servers running without authorization controls.
It is a perimeter-sized hole in zero-trust architectures. If you have an MCP server that allows a model to read your database, and that server is exposed to the web without proper authentication, you are essentially leaving the keys to the kingdom under the doormat. Developers are so excited about the productivity gains that they are sometimes bypassing the standard security guardrails. The harness is powerful, but it is also a massive attack vector if it is not configured correctly. We are seeing a lot of CISOS scrambling right now to get a handle on how many of these servers are running in their environments.
Speaking of productivity, the numbers Anthropic put out are wild. They claim their own internal engineers are using Claude for 60% of their daily tasks, resulting in a 50% productivity gain. And we are seeing that reflected in the benchmarks too. On SWE Bench Verified, Opus 4.6 is hitting over 80%, but the one I really care about is SWE Bench Pro, the one where they try to eliminate data contamination.
The Pro benchmark, which is managed by Scale AI and their SEAL leaderboard, is much more telling. Opus 4.6 is scoring between 46 and 57% there. To give some context, the baseline in early 2025 was around 15%. We have tripled the autonomous problem-solving capability in about a year. We are moving away from benchmarks where the model might have seen the answer in its training data and toward live environments where the model has to truly reason its way through a novel bug. It is the difference between memorizing a map and actually knowing how to navigate a forest.
I want to talk about the shift we saw just a few days ago, on March 20th, with the launch of Claude Code Channels. This feels like the death of what people were calling the hardware tax. Do you remember last year when everyone was buying dedicated Mac Minis just to run autonomous agents 24/7?
I remember it well. People were running things like OpenClaw on local hardware because they wanted their agents to work while they slept, but they did not want to leave their primary laptops running and overheating. Anthropic basically solved that by moving the execution environment into these asynchronous channels on Telegram and Discord. Now you can start a massive multi-hour refactor on your terminal at work, close your laptop, and go home. The Agentic harness continues to run in the cloud, and when it finishes the job or hits a blocker it cannot solve, it pings you on Telegram.
It changes the relationship from a synchronous chat to an asynchronous partnership. It is more like managing a person than using a tool. And with the release of version 2.1.76 on March 18th, they added agent teams. This allows a single Claude Code session to spawn subagents to work on different parts of a problem in parallel.
The technical implementation of agent teams is fascinating because they are all operating under a single parent context window of 1 million tokens. So you have one subagent working on the back-end API logic, another subagent refactoring the front-end components to match, and they are both feeding their progress back into the parent context. The parent acts as the architect, ensuring that the two subagents are not drifting apart or creating breaking changes for each other. This is how they are hitting those high SWE bench scores, by breaking down massive problems into smaller, manageable tasks that are coordinated by a central brain.
It is a massive amount of orchestration. When you look at the competition, like Devin from Cognition AI, they take a very autonomous, almost hands-off approach, where the agent lives in its own custom sandbox. Claude Code feels more like it is designed to stay close to the developer's existing workflow in the terminal. It is not trying to replace the IDE, it is trying to become the engine that powers it.
And that is why the state persistence files are so important. I mentioned claude.md and memory.md earlier. Those are not just documentation, they are the way the harness solves the stateless brain problem. If you tell the agent once that you prefer a specific functional programming pattern or that it should never use a certain library, it writes that down in claude.md. The next time you start a session, even if it is a week later, the harness reads that file and immediately regains that project-specific intuition. It does not have to be retrained or reprompted from scratch.
It is building a persistent project brain. I think that is a great takeaway for anyone using these tools. If you are not actively curating your project-specific markdown files for your agent, you are wasting half the power of the harness. You need to treat those files like you are onboarding a new hire. You have to be explicit about your standards.
You really do. And you also need to be auditing your MCP server exposure. If you are running an open source server from NPM, you need to make sure you are not inadvertently exposing your local file system or internal databases to the wider web. The productivity is intoxicating, but the security debt can accumulate very quickly. We are seeing a shift from prompt engineering, which was all about how you phrased a question, to harness orchestration, which is about how you manage the environment the agent lives in.
So, what does this mean for the role of the developer? If we have these agentic harnesses doing the heavy lifting, running the tests, and even notifying us on our phones when the job is done, are we still programmers in the traditional sense?
We are becoming architects and code reviewers. Our job is shifting from the manual labor of syntax and debugging toward the high-level labor of system design and verification. You still need to know how the code works because you are the one signing off on the commit. You are the one who has to understand the architectural implications of the changes the agent is suggesting. But the days of spending 4 hours hunting for a missing semicolon or a misconfigured environment variable are effectively over for anyone using a modern harness.
It is a bit of a transition. I think some people will find it difficult to let go of that granular control. But when you see a 50% productivity boost, it is hard to argue with the results. You can build twice as much in the same amount of time, or, more likely, you can build things that were previously too complex for a single developer or a small team to manage.
That is the real promise here. It is not just about doing the same things faster, it is about expanding the scope of what is possible. We are seeing small teams of 2 or 3 people building platforms that would have required 20 engineers just 3 years ago. The harness is the force multiplier that makes that possible. It is the realization of the one-person unicorn dream that people were talking about at the start of the decade.
Well, I think we have covered the moving parts. From the agentic loop and the thinking budget to MCP 2.0 and the new asynchronous channels, it is clear that the term harness is exactly the right way to describe this. It is the infrastructure that makes the intelligence useful. It is the difference between a brilliant idea and a finished product.
I am curious to see how the security landscape evolves as more enterprises adopt this. That perimeter-sized hole we talked about is going to be a major focus for CISOS throughout the rest of 2026. We might see a new category of security tools just for auditing MCP traffic.
No doubt about that. We should probably wrap it up there. If you want to dive deeper into the technical evolution of these models, we actually did a deep dive on transformer architecture and the shift toward cognitive reliability back in episode 1080. It provides some great foundational context for how we got to this point with the Opus model family.
And if you are interested in why agents sometimes fail despite all this infrastructure, check out episode 1078, The Agentic Throughput Gap. It explains why your AI hits a wall and how things like agent teams are designed to break through it.
Thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power the generation of this show.
This has been My Weird Prompts. If you are enjoying the show, a quick review on your podcast app really helps us reach more people who are interested in this kind of deep dive technical discussion.
You can also find our full archive and all the ways to subscribe at myweirdprompts.com. We will see you next time.
Take care.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts.